Now.
I think these would be.
Hmm?
Those are them
Oh,
right there,
yeah.
right?
That's what they look like.
Yeah, that's in the Brunswick. I saw that the other day.
Oh, yeah.
It's Brunswick, Georgia. That's how the public look. Oh, whoa.
Because you connect more than one together.
Yeah.
8
So
exam
you're able
questions.
to each one.
Out of sub-element 7.
Well, is it 8
There's
exam
10
questions?
sub-elements.
Yeah.
Okay? And each sub-element has 2 to 8 groups.
Right.
Okay. This one has 8 groups.
So you get one question out of each group?
One question out of each group.
Okay. But
And
it's
the-
power supplies.
And the groups are typically 10 to 15 questions per group.
Mhm.
I'd like to see how they set up.
Okay, so we're talking about power supplies, regulators, and solar array chargers.
Yeah, this is a pet peeve of mine. When you buy a power supply today, it comes with a little knob to change the,
Maybe
mine does.
they don't all have knobs.
Oh, and I went, whatever happened to linear power supplies? I mean, Jesus.
Well, they're still out there, they're just expensive, and then they're even more expensive to ship, those are so.
Yeah.
Yeah,
But Jesus,
Everybody wants to buy stuff.
my power supply's got a knob on it and it doesn't affect voltage. Yeah.
mine's got a knob and 2 switches.
I got one.
One I can disable the knob
Ooh.
and have fixed versions, see?
Ooh. High tech.
And one turns it on and off. And a meter
Oh,
on one of them.
you bought the fancy one.
But I got 2 that don't have meters.
Okay.
Okay. Linear power supplies. They're called linear because they use linear ICs or voltage regulators to maintain the constant output voltage. And they do it by varying the conduction of current or the amount of current through the control element usually called a pass transistor.
They call it a 2-inch 3055.
That was one of the old ones, and they're still around. Typical circuit, and the Q1 is the pass transistor, and that's where we're going to actually use it kind of like a variable resistor or a controlled current source. So depending on the required output voltage, you'll vary the conduction of that to drop it down from in this case, the 25 volts to the 12 volts. And you do that with the voltage reference down there, D1, which in this case, that's very typical, is a Zener diode.
Yeah.
Okay. So it's kind of in a constant state. It's very stable that way. It makes a very good reference source.
Mhm.
So in this case, it's probably going to be a Zener value of what would that be? 12.7 volts?
Yeah.
To get 12 volts out.
38.
No, 12.7. If we want 12 here.
Oh, okay. Okay.
And this is not adjustable. It's kind you like. No knob. So Q1 is called the pass transistor.
Well, we don't need knobs to play with. I mean, it doesn't have a knob on it. Why have it?
He's saying 13.7. If you wanted 13.7, you'd go to 14.4.
Yeah.
Because the Zener.
Right, because you've got to offset
By
that.
the Zener.
By 0.6 or whatever it is.
So C2 is just the called bypass, but it's really a filter capacitor to filter out the any ripple. R2 would be the load resistor, and usually, even with internally, you'll have a load resistor on it just to dissipate the capacitors instead of having them stay charged up. If there's multiple capacitors, you'll have resistors around each one to equalize the impedance resistors to equalize the voltage over time and discharge them. And then D1 is your voltage reference, which in most cases would be a Zener diode like that. So what type of circuit is shown in figure E7-2?
Linear.
A linear voltage regulator. So how does a linear electronic voltage regulator work? We control the conduction of the control element. What's the purpose of Q1?
Current. Let's see.
What's the function of the pass transistor in a linear voltage regulator circuit?
Constant voltage.
Yeah, I think they want you to know that.
Yeah,
Concentrated on.
would come in handy, yeah.
So what's the purpose of C2 in the circuit?
The ripple, right?
Right.
Well, wouldn't that be C3?
No, you're trying to maintain a DC voltage on the Zener. So your input,
Smooth.
okay, may not be a perfectly smooth DC.
Okay.
If that would jerk around your output, if it had a rip, it would be just, would worsen everything, wouldn't it?
Well, if you had,
Your stable output would no longer be stable because it would.
right, because if the voltage across the Zener is changing, even though it doesn't affect it a lot, the Zener voltage is going to vary slightly. Because they don't, when the avalanche is at the Zener, it doesn't go perfectly straight. There's some internal resistance, so that would affect the reference voltage, which would affect the output voltage. So again, D1 is the Zener, used as a reference. So what device typically is used as a stable reference?
Oh, geez, let me think.
Have we heard that before?
Yeah.
I would have to go.
Okay. You can have two kinds, and we've only shown a series regulator. There's also a shunt regulator where it's a lot less efficient, but you've got a constant load on the source because whatever load is not, or current is not being consumed by your output or load is carried through that shunt regulator. So when there's nothing connected to that power supply, you got the full amount of current that the power supply is capable of going through that shunt and dissipating power in that circuit. So
Lovely.
it's very inefficient.
Lovely, yeah.
You don't see those that much.
Room heaters,
Huh?
a room heater. Yeah.
But its advantage is it provides a constant load to the input,
Okay,
and they do regulate. It's just,
If you could use that shunted power somewhere else for.
Yeah.
Maybe a little light comes on.
yeah, you just put a lamp in series with it, and of course it would vary depending on your load, be inversely proportional. So which of the following types of linear voltage regulators usually make the most efficient use of primary power source?
a series regulator.
A series regulator. Which of the following places a constant load? On the input,
Sharp regulator.
okay, dropout voltage. There will be, depending on the pass transistor, normally, there will be a certain amount of minimum voltage that you have to supply above the output voltage.
I said slide, but I would have said 3 volts, not 2. In my personal experience.
Well, I just made up those numbers.
Oh, did you? Oh, okay.
Yeah.
All right. Well, then you must be right then. Yeah.
So if you wanted 9 out and the voltage dropout was 2, then obviously you need 11 or more
Yeah.
in,
12 more.
you know. But at least 11. You've got to have more, at least the dropout voltage or more. Normally,
What about
you
the
want to operate higher than that.
3-legged fuses?
The what?
3-legged fuses, 7805, 7809, 7812. The differential on those is more than 2 volts, I think.
I don't remember.
It's been a long time. I don't remember.
I just made up the number.
Did you really?
Yeah.
Very impressive.
It seemed like this a reasonable
Yeah,
number.
I know.
The example was is 9 plus the dropout. You missed the point.
You didn't miss the point. You got lazy. I see. Yeah.
So it's the minimum input to output voltage required to maintain regulation. What is the dropout voltage?
Probably
Oh, skip
the minimum now.
No, Bob said 2.
No, in that particular case. The minimum input output. Let's see. For a series connected, you see the power dissipation in the regulator itself is going to be the voltage difference between input and output multiplied by the current. So it's the, power law. Voltage times current. And it would be real power or heir apparent power, which? Real power. Probably. However, if there was reactance, it would be apparent power.
That's cheating. You just can't throw that in there. It's
Uh,
it's not an RF circuit, Bob. It's okay.
Yeah, it should be resistive. Okay. So the only thing there about the power dissipation is having to have large heat sinks, the more power you dissipate in it. So, you don't want to operate a 12-volt supply off of 110 volts. You're going to dissipate a lot of power, dropping it down to 12 or 14 volts.
Well, that's what transformers for.
Right. That's why you convert it down to 15 or, well, maybe 20, something like that.
Because the other would be just wasted, right? The difference between 120 and 12.
Right. I mean, you could just rectify 120
Yeah.
into DC and do it,
Makes more sense.
but you're going to dissipate a lot of power doing that. Because you got to get rid of that difference between your output voltage and the input voltage. So that's why you normally would have a big power transformer in a linear supply.
Right. Just step it down and preserve your power and just by transferring it to the like you'd only have 12, you'd have 12 volts, but you'd preserve your power by having more current in a transformer.
Okay, what's the equation for calculating power dissipation in a series linear
Voltage difference.
Voltage difference.
See,
Okay. Switchers, your favorite,
Oh,
and they become more popular.
I know,
It's hard to find a linear,
I know.
especially if you have to order it and pay shipping. They use a different method of regulating, where they vary the duty cycle, kind of like a Class D amplifier.
They're noisy.
They may be, but
Hmm.
most of the good ones are pretty good about filtering out the noise. But the basic difference is they vary the duty cycle on the control element, as opposed to just doing a linear control.
You see it best on an SDR, when you get the whole band up, then you turn the knob on your switching power supply and you watch the whole display go crazy. You know,
Okay. So what's the characteristic of a switching electronic voltage regulator?
like any of them.
You don't.
But C is the closest, I guess.
All right. You only have to go with the closest one.
Okay. I think one of the choices should have been cheaper, less shipping cost.
That's true. Well, right here, it's less
No,
expensive.
now you come to.
It's lighter.
Yeah,
You
yeah,
can hold it in your hand,
yeah,
where it takes two hands for a linear.
or more.
It's higher, it's more efficient. One of the things they don't point out is it can help the rest of your power dissipation in the house because it can have a negative resistance.
How could it have a negative resistance?
Well, what is resistance? The ratio of voltage to current, right?
Yeah,
What happens on a switching power supply if you reduce the input voltage? The current goes up.
Okay.
Well, think about that.
well, that's,
If I decrease the voltage and I increase the current, the resistance has to
change,
has
obviously.
to be going in the negative direction.
But I can't think of an application where that would be true, though.
Well, it's true on any of them if your voltage drops. If
Well,
you get a brownout, your switching power supply is going to draw more current, which is going to make the brownout worse.
That's a good point.
I mean, for a little, when it's not a big deal.
So. So the chance with the cheap one is that it'll be noisier,
Yeah,
so the quality.
I'm not sure how you tell without doing research
the
or trying
quality
it.
of the switching power supply is the filters and.
But the Samlex and the ones that PowerWorks sells and some of those Astron, they have pretty good reputation. They seem to be pretty good. I don't know if I would trust one from Amazon.
Right. So anytime you pick up a power supply with one hand, it's a good bet. It's a
Switching.
Yes,
power.
good bet.
I remember years ago, I used to have one of the old fashioned automobile battery chargers, right?
Yeah.
I think it was a 10 amp one, might have been a 6 amp or 10 amp, but but the darn thing must have weighed 25 pounds, So when it wore out, I had to replace it. And of course, I bought a current one, so it weighs about 4 ounces now.
Right.
I-
As a display and everything.
So I took the old one apart. I was going to throw it away, and I saved the transformer on it, just out of principle. I still have it.
Yeah.
I'll do something with it. I mean,
Yeah,
you
you
just
just have a lot of that going to do something with stuff.
yeah.
So what's the primary reason a high frequency switching type high voltage power supply can be both less expensive and lighter in weight?
No transformer. Where's that on here?
Oh, they'll have a transformer.
Uses smaller.
Well, smaller transformer.
It'll be a ferrite
Yeah.
or a toroid,
It'll be an inductor, something.
very small, just big enough that it'll handle the amount of current.
So C is as close as we can get to.
C is as close as we can get.
Okay.
Uses smaller transformer and filter components. because you're filtering much higher frequencies, so
Yeah.
you don't need a farad capacitor. And normally they only do it with capacitors. They don't put inductors.
You have farad capacitors?
Farad, yeah.
I only have microfarad capacitor. I don't have farad capacitors.
Well, they're called supercapacitors.
How big is it?
Oh, they're surface mount even. Not very big.
For a 1 farad?
Yeah.
At what, 1 volt? I mean,
No, a couple volts,
yeah.
like 3.
Okay.
They use them in the pico balloons.
A pico,
Balloon.
what's that?
Oh, well,
Amateur balloons that you send up and they're tracked across the.
No, these days you get arrested. You're a Chinese spy the minute you put a balloon up with a.
no. Actually, there's one. I haven't. Have you checked it recently? It might be close to its 5th pass.
Yeah, it's one of them.
Yeah,
Hmm?
I just had a class up in, on Starlight Beach.
Really? Yeah, I had no idea.
Yeah, I think I was at a class on,
But
I don't get out very much. I mean,
Yeah,
the
you
guy had 100 balloons for free. The balloons.
Yeah.
balloons, and-
well,
the kids.
the Space Hobbies is going to have another seminar in November, December. I think in Sebastian at the library, where it was last time, and they're going to give away 100 kits, not just the balloon, the
I
tracker.
was a kid, you know.
Yeah.
They gave away a bunch of SDRs a while back.
Yeah, I know. I have a couple. But anyway, and these go up about 45,000 feet. You get above the clouds,
Mhm.
because if they don't, they ice up and they come down. Well, what do you think the temperature is at 45,000 feet?
30 below zero?
75.
Oh, okay. All right.
What do you think doesn't work? Batteries.
Everything, yeah, yeah.
But supercapacitors do.
Yeah.
So they charge the supercapacitor from the solar array.
That
That's,
thing's gonna weigh 30 pounds or something like that.
oh no.
It's a little bitty thing.
Really?
It's this size of this gizmo there.
Oh, it's not that big.
Yeah, you're just,
Just amazed. I've never seen these. Yeah.
go look it up. It's on what thing.
Yeah.
Next video. Guy
I'll-
fly on the.
I'll show you a picture.
All right. I'm ignorant.
We're still.
We're
Okay.
still recording. Oh my God. We didn't see any bad words.
Yeah,
No, but
that's right.
if you wanna watch this lesson, it's gonna be like 30 minutes.
Okay.
To get
No
one
more
question
sidebar
answered.
conversation.
Yeah.
That's that.
Okay.
Using the trim function later.
High voltage supplies. Well, most of the modern transceivers operate on 12 volts, which is really 13.8 volts. And the supplies usually put out about 14 normally.
Mhm. Mhm.
The old tube types were, 200, 300 volts, maybe more. So they had high voltage supplies, and a lot of times they would use what's called a step start or a soft start circuit. Sometimes you even see it on power tools where they're going to draw a high amount of power.
Only when the lights dim would you turn something on.
But it's basically a circuit that allows it to charge the capacitors up slowly so you don't get this big surge. Sometimes you can do it with a thing called a varistor, which increases,
They can go either
or
way.
actually it decreases its resistance as the current goes up. So it's kind of an opposite
Actually,
thing.
its temperature goes up.
No, current. I've used them on my CNC stuff.
Yeah, but it's-
Varus, right?
Yeah, I think it's called
Not a thermos.
right.
Oh, I'm thinking thermostat. Right, absolutely right.
It's a current controlled variable resistor. And it's kind of like a negative. The more the current increases, the resistance of it starts to go down. So it's a high resistance initially. Kind of like the way an inductor works with frequency. Typical circuit showing in this case, it's a relay that switches the series resistor in and out. I think they're a little more sophisticated now. It seemed like an awful lot of circuitry just to do a soft start. Because that's not the power supply, that's just what's going to the load. So what's the purpose of a step start?
Charge capacitors gradually.
To allow the capacitors to charge gracefully. Okay, you got filter capacitors in the power supply, regardless of whether it's just linear or switching. They'll be smaller in the switching supply because you've only got to filter out high frequencies as opposed to 60 or 120 hertz type. When you have multiple capacitors, you put resistors across each one to equalize the voltage over a long period.
You'll live longer.
They will discharge it over time. Okay. So you don't have charged up capacitors in there if you happen to take the cover off and start playing around. And they provide a minimum load. In some cases, you actually need a load on the power supply. That was the thing and I'm sure you must have taken some old AT type power supply, PC power supplies
Of course,
and converted them.
of course.
And they don't work unless there's a load on them.
No, they were fine.
You gotta have a load resistor.
I never had a problem with that.
You probably had it hooked up to something. Open circuit, they don't work.
Well, there was a plug.
But then that doesn't matter. They don't do much open circuit anyway.
They really don't.
Okay. What's the purpose of connecting equal value resistors across power supply filter capacitors when they're connected in series?
All of them.
And the only reason you would have them connected in series is to increase the voltage, right? Because you're reducing the capacitance. So the only reason you put them in series is you need more voltage.
Okay, yeah.
Solar array controllers. I don't know anything about these except what it says, but it makes sense. Apparently you have to buy a solar array controller to use your solar array to charge a battery, particularly if they're like lithium batteries.
No, even lead acid, I've got them on my boat, that one.
Okay. Solar panels, they claim if they're rated at 12, they actually put out 16 to 20.
18, yeah.
18, okay.
Yeah.
Well, 16 to 20 is pretty
Yeah,
close.
yeah.
And they probably get that by using the half a volt per cell when it's fully illuminated, but they don't tell you what the voltage is under load. So that's probably part of the reason why instead of 18, you're actually getting 12.
Mhm. And the new style ones are MPPT,
And what?
the solar controllers, MPPT.
What's that
I
mean?
think, is that right? MPPT?
No, you're right.
Yeah.
Yeah.
And, oh, well, okay, you got 18 volts,
Right,
okay? Your batteries are 12.
right.
You're using them to charge your batteries, right? Well, okay, so you're gonna use 12 volts, that's it. Well, what about the other 1/3 of the power that your solar panel's putting out? So what these things do is they play with the voltage, right? And you get to use all of the power going to the battery, and you're not leaving any of it behind. And that's basically all they do.
Oh, okay. Cool.
They also want you to take, apparently the charging of the solar panels is better at, I think, at 36 to 48 volt. Like a solar panel, it charges at 48 volts, it converts it down to 36 and then goes down to the battery at 12.
Well, yeah,
Because there's an efficiency thing up there somehow.
if you're getting, let's say, 100 watts out of your panel, you'll actually get 100 watts into your battery.
Or almost.
Or, yeah,
Okay.
yeah, that's the.
Cool.
There's no losses in solar.
Right.
No loss.
Oh,
Well, there is in that controller.
Oh,
And there is when there's a cloud.
Yeah.
Or when there's dust on
Or a shadow over your panel.
it, or if you're at the North Pole.
Yeah. Well,
Okay,
no, in the summertime, that could be good.
yeah, but you get less, because of the angle, you get less effective light.
That's-
But the big thing here is to prevent damage from overcharging your battery. That's the question. What's the main purpose?
Oh, dear, let me guess.
Prevent battery damage due to laser shock.
Oh,
Okay,
that was one solar question?
That's it. So, that's it.
and see, what's the odds of getting it? 1 out of 15? 1 out of 15?
Was it 100%? Cause you have that one question from that.
Each group, right?
One from the group, yeah.
Well, that's the one, that only one.
Well, we covered
Oh, too many groups.
7 questions today. All that was just result in 7 questions.
Thank you, Mr. Bob.
No problem.
Gentlemen, that's been a pleasure.
Is there more after this?
No, unless you want. I've got next week's done, but I was,
I'm so
It
sorry.
didn't say takeaways, that's why I was
oh,
waiting.
well,
Flat out.
I never had time to go back and fill those out. I've done them before. But